part of the before I go any further, I also just want to make everyone aware. Some of you were at the event last year. Put on your calendar, and of course, Margaret in the back. I did say Margaret, did I? I did. Thank you. Thank you. We are working. It's a two-man comedy duo here, and I'm usually the straight person, and then we're kind of be the color player here. I consider myself kind of the Dean Martin of the bunch here of the duo. Um, Remember the capital refractive surgery forum, please. It was a great event last year. I'd love to see if everybody's able to make it. It's very, very different from what is typically, or we like to make it very different. We've got some really interesting updates this year. A lot of great speakers, very high impact, short lectures. Really try to give you, intensity as far as information without kind of the draw out that we sometimes find ourselves in. And so I can't go any further without making at least a plug for the forum later this year, September 20th, 2026. I'll say that twice again. Same venue, Columbia Country Club. Register early, save yourself some money. September 20th, 2026, Columbia Country Club, Capital Refractive Surgery Forum. Moving right along. Our speaker this evening is kind of a deviation from what we have discussed in the past. And I think based on obviously the attendance here, it kind of strikes a chord with everyone. Because it seems when I saw some of the early reports and in the journals, it was such a novel way of approaching holistic care. I think that's really what it is, or wellness. Dr. Cecilia Lee is a clinical researcher, retina specialist by training, as well as an ocular inflammatory specialist by training at WashU, who has specialized in detecting diseases like Alzheimer's and diabetic diseases of the eye as a combined researcher of retinal imaging, patient data, and the hottest subject of all is artificial intelligence to better understand aging and overall health, which is just absolutely fascinating. She is the Jane Hardesty Poole Distinguished Professor at WashU, as well as a principal investigator at multiple NIH-funded research studies of the eye, both the biomarkers for Alzheimer's disease and dementia, and leader of the Eye Act study, of which I think we're going to hear quite a bit about this evening. One of the nation's leading longitudinal studies exploring retinal biomarkers and cognitive decline. Every day in clinic, I'm always asking myself if I forget something, and Margaret can certainly back me up. I'm like, am I on the decline now? Is this something that is this one of those seeing? So why are you taking a minute? They're like, wait a minute. I'm still young enough that I shouldn't have any of those cognitive biomarkers. But in truth, I guess we'll rely on Dr. Lee to kind of point that out, to kind of guide us. I suppose with that said, I want to once again thank Dr. Lee for agreeing to be here tonight. This is been a very different subject, but it will affect all of us in the room, certainly professionally as eye care providers, and hopefully give us a very different perspective on how we approach each and every one of the patients. I will give you the lectern here virtually. Do I have to pick anything? Okay, so it's all yours, Dr. Lee. Thank you again for agreeing to speak with us. Or you might be on mute still. You're gonna unmute yourself. I think so.
Got it. Okay. Hello. Hi. Okay. Well, thank you so much, Dr. Solomon, for such a nice intro. And then Rebecca has been really great setting this meeting. And I really I wish I were there, but I really want to thank you for this opportunity. Okay, so my topic is today just looking at the eye and using the eye as a window to the brain. And then really I want to talk about how our lab is really integrating big data and emerging AI tools to gain insights into our systemic health and overall aging. So I'm going to be talking about just this concept of oculomics and then how our journey has been about connecting the eyes to the brain. I'll mention a little bit about new initiative that's happening on AI and machine learning, and I'll end the talk with future directions. Hopefully, we'll have plenty of time to ask questions and discuss more. Okay, so I'm hoping many of you have already heard the term called oculomics. And this term was actually coined, I would say maybe 3 years ago. Everybody's talking about omics, right? Genomics, proteomics, and then now radiomics, and then now it's oculomics. And it's really about leveraging advanced ophthalmic data, such as retina imaging, but not necessarily, not only exclusive to retina imaging, but really using the advanced eye-related data to understand the overall health. But this idea of using the eye, I'm sure you have heard or you have used the term like eye as a window to the soul, eye as a window to the brain. You've heard that many times. And so this concept of oculomics is not new. I would say actually this was really present in the dawn of ophthalmology history. That in 1898, Marcus Gunn, of Marcus Gunn, I mean, Marcus pupil, he had already observed, I mean, this is like from the great observers, where he had already described how the arteries have an exceptionally bright reflex, that the retina looks already different in people who have hypertension and chronic renal changes. And then I think this was in 1906, the ophthalmoscope, the Journal of Ophthalmoscope has already talked about how the retina already shows differences in people who have hypertension, anemia, and chronic kidney disease. So this concept of understanding our systemic health through describing exquisitely in details or really observing with careful eyes from the eye has been there with us for, more than hundreds of years. And when we went to med school, or when we are studying about the eye, we are familiar with Kansky Atlas in terms of talking about the eye and systemic disease. What are some difference? What happens? Like, why do you see macular edema or macular papilledema, and those kind of questions. So there is definitely biologic relevance in terms of us being able to ascertain the health of this our body through the eye. So we just published this paper on evolution of oculomics, where we really went from a naked eye, and then, in the advent of ophthalmoscope in 1850s, we were trying to describe what we see. And then we got FA involved. We had an SLO. And then really in the 1900s, in 1990, that's when the OCT, 1991 was the initial OCT description. And then in the early 2000s, we went from more descriptive to semi-automated image analysis. And now in 2016, we really entered the AI era. And then I feel like maybe 2 years ago, that's where the ChatGPT era started, and that's another hypes of this revolution of AI and big data. So what do I mean by this ophthalmic big data revolution? And it's because we are trying to understand, we are trying to leverage all this data to not only diagnose eye diseases, but we really want to leverage those eye disease diagnoses to understand what are the systemic disease connections. And even better, can we leverage the eye to predict who's going to develop, these other diseases that may be preventable, such as stroke, cardiovascular complication. What if I were able to do a fundus photo and then say that your risk of developing, heart attack in 10 years is 70%, therefore you should be on statin. And just providing some background in terms of like the wording. So we know that the artificial intelligence is a concept or is a term that started in 1980s, I think. And then within the artificial intelligence, there's machine learning. And within machine learning, there's deep learning, which is quite good at really analyzing images. Within deep learning, there's generative AI, and then within generative AI, there's LLM. And I really like this Venn diagram because I think it shows how big data is really needed to train sophisticated AI models. And then sophisticated AI models are needed to interpret those big data. So big data is really at the center of us being able to leverage those new tools that are advancing every day. Now I'm going to move on to our journey in terms of connecting the eyes to the brain. I'm sure everybody knows here that eyes are the direct connections of the central nervous system. I mean, like, you've studied a lot about that, and then we know that during embryologic development, the eye really comes out as an outpouching of the forebrain within the first 3 weeks of our embryology, and because of that connection, there is really scientific promise or biological plausibility in terms of why looking at the eye will really help us understand better the brain. So, more than 50 million now live with Alzheimer's and other forms of dementia in the world. And every 65 seconds, someone in the US develop Alzheimer's disease. And Alzheimer's disease is the sixth leading cause of death in the US. And then it's the only one out of top 10 cause of death in the US without any, preventable or, effective treatment. We know that by 2050, it's going to triple the number from 50 million to 153 million. So we are in a, in a public health crisis regarding Alzheimer's and dementia, especially with our growing older population. So we are using the eye as a window to the brain and really try to leverage the sophisticated computational tools to understand all the data that might be available from the eye. So going back to the reasoning why we can use the eye as a window to the brain is because we mentioned they share embryologic origin. They have very similar vascular properties. We talk about blood-brain barrier. That's the same concept as blood-retinal barrier. We have many, many clinical studies, populational cohort studies that have shown relationship between certain eye diseases, such as AMD, to Alzheimer's disease. Although things are conflicting, and I'm happy to talk to you more about why we have so many conflicting results. And what is really remarkable, and then what really makes ophthalmology stand out, is really the availability of accessible and scalable imaging. This is the only organ where we don't have to cut and then really look into blood vessels and then blood flow. We just need to look into the eye. Are we okay, Rebecca? Can you guys hear me?
Yep. Keep
Okay.
going. Keep going. I'm going to throw in some questions at you, Dr. Lee, just a bit, but you're good for now.
Okay, I couldn't quite hear you. Are we okay?
Yes,
Okay,
excellent.
okay, great. Okay, so then, so I'm gonna start with the first example of our journey. So I'm gonna talk about a little bit of background of ACT study. It's an adult changes in thought study. This started in 1994 in the metropolitan area of Seattle. So this is in collaboration with Paul Crane at University of Washington and Eric Larson, who used to be at Kaiser Permanente, and then now he's at University of Washington. So they started a study in 1994. They gathered about 2,000 participants who were all part of Kaiser. Well, it used to be Group Health earlier. So they were part of this HMO. They were either 65 or older. They were all cognitively normal when they got recruited. And every 2 years, they were followed. And then if they went below the threshold for cognition, they went through another battery of testing. And then they were diagnosed with what we call research criteria Alzheimer's disease or other related dementia diagnosis. That is the highest quality diagnosis that we can give because, as you know, the definitive Alzheimer's diagnosis cannot be given unless we have brain autopsy, unless we are, looking at the brain. So obviously, the clinical diagnosis that we can give of the best quality is through this consensus criteria of the research criteria diagnosis. And what is really remarkable of this study is that they were all part of Kaiser, so they all had equal access to all the comprehensive medical care. So, as part of the study, they got enrolled every 2 years, they got cognitive testing, and they were followed until they developed any type of dementia. And about a third of participants do sign up for autopsy. So, then we actually have more than 1,000 brains that have been autopsied and graded. And what is really remarkable is that because they were part of this medical system, we were able to access to all their medical data and records, including surgery, blood, medication, and all the imaging. So our first question was, well, are there any diseases? Specifically, we wanted to find out about age-related macular degeneration, AMD, glaucoma, and Dravet retinopathy, not only because they are very prevalent diseases in older adults, but also there is rationale for thinking that there is a neurodegenerative component to all three diseases. We asked, if you have those eye diseases, what is your risk of developing Alzheimer's disease in the future? So we had data about 3,900 participants of 31,000 person year data and almost 800 Alzheimer's disease incident cases. So this is the forest plot that summarizes our result. So this is forest plot where it shows if it's one hazard ratio one, that means no risk. If it goes towards the red, that means that it's harmful. So we know that age is an important risk factor for Alzheimer's disease. So that's going to be to the right. If it's to the left or to the blue side, that's going to be protective. And I want to congratulate everyone because we are being educated. This kind of educational, occasion will be protective against Alzheimer's disease. So here, and we know that ApoE4 is a lipoprotein, and it's the highest known or the strongest known genetic risk factor of Alzheimer's disease. And in our cohort, that is about 50 to 60% increased risk of developing Alzheimer's disease. What was really astounding was that if they had a previous diagnosis of AMD or diabetic retinopathy or earlier type of glaucoma, then they were all at increased risk of Alzheimer's disease. Not only that, but the effect size of that is incurred by having glaucoma, diabetic retinopathy, and macular degeneration were actually similar to somebody having that genetic risk factor that I told you about. So it's almost, I can actually look into somebody's eye and can tell them that their risk of developing Alzheimer's disease is, similar to somebody having that genetic testing. So we published this paper, but really gave us this assurance that, well, there are certainly very significant relationship between eye diseases and the brain and Alzheimer's disease in particular. But what about the eye or what about those eye diseases? And that's kind of what really led to subsequent studies. So I went to school for epidemiology, and then so I get really excited when we find new risk factors that we didn't know about. But one of the, important, predictor, the quality of predictor is whether you can modify that risk, right? I mean, nobody's going to be excited if I say, oh, well, old age is related to higher risk of Alzheimer's disease because like it's not like you cannot age. But if it's something that you can actually do something about it, then that's even better and it's even more exciting. So I had mentioned that there are eye diseases that are associated with higher risk of developing Alzheimer's disease. So then we asked, well, what if we intervene to increase or improve the health of the eye? Can we actually have an impact of their risk of developing Alzheimer's disease and dementia? So our next study question was, is cataract surgery associated with lower risk of developing Alzheimer's disease? And we chose this question because cataract is not a disease per se, it's a complication or it's just a reflection of aging. But if we can halt that, or if we can improve the visual outcome after fixing cataract surgery, we wanted to know whether does that actually have an impact on future risk of developing Alzheimer's disease. So on this study, we had more people's data. So we had about 5,500 people's data, and then we kind of followed a lot more history. And it's important to mention that we did survival analysis and we used surgery as a time varying exposure because sometimes it's really important to make sure that we are not biasing our results because this is an observational study, and then obviously you need to make sure that we're not just getting results because of many confounders that we could not control for. So this is again forest plot. So the top panel, the outcome is all-cause dementia, and the bottom panel is the Alzheimer's disease dementia. So I'm asking, what are the variables that would be associated with higher risk of developing dementia or Alzheimer's or protective? So the first one is if somebody does not have ApoE4, so it's the opposite of having that ApoE4 allele. So obviously it makes sense that it will be protective from having Alzheimer's disease or other dementia. But what we did not anticipate was that if somebody had cataract surgery, actually their risk of developing dementia and Alzheimer's disease went down by 30%. And remember, I said that I was doing it as a time varying covariates so that we were actually looking at the impact. Is it just, is this lowering risk of dementia and Alzheimer's? Is it just for 1 year, 2 years, etc.? And then it was remarkable that there was still significant difference among people who underwent cataract surgery and among people who did not. This difference was still significant even after a decade following cataract surgery. Now, you might say that, well, that, I don't know. I mean, it's kind of pretty shocking to say that, if I were to develop a medicine that can decrease the, Alzheimer's disease risk by 30%, I'm sure I will be really rich. So then we were thinking, well, there are a lot of confounding. There are a lot of secondary risk factors that we need to analyze. So we actually drove our biostatistician crazy. So we even looked at, well, what is your, rate of exercise? Are you more likely to see the doctors? Are you, do you take good care of yourself? Are you depressed? So many, many secondary analysis, and then they all came down to about 30%. But one thing that we were still scratching our head was that, well, there's no question that people who are signing up for cataract surgery, they are healthy. If you are, in ICU with, heart failure or you just had a recent stroke, you're not going to come for outpatient surgery and have cataract surgery. So what we wanted to compare is that we wanted to compare that population to people who are signing up for glaucoma surgery. Now, the indication for cataract surgery and glaucoma surgery is obviously not the same, but we thought that, well, that is a pretty good control group because, people who are able to sign up for an outpatient intraocular glaucoma surgery, they must have some type of similar health or similar condition that they have the ability to come and have surgery. And when we compare that, again, this is the our result, that primary model where we compared what is the impact of cataract surgery and their risk of developing dementia went down by 30%. Hazard ratio was 0.71. But when we compare to people who had glaucoma surgery, the hazard ratio 1.08, but it was really, flanking among around one. So it was really a null. There was no risk or there was no protective effect. So, um, so this was kind of really reassuring, saying that this is not just about somebody being healthy enough to come and have an intraocular outpatient surgery, but the impact was very specific from having cataract surgery.
Dr. Lee,
But
can I pause you for a second? Can we go
yes,
back to that slide for just a moment? And just so,
yes,
all right. So does everybody get this so far? We're all on the same page? All right. You're better than I am because there's a lot of data in here. And as somebody who also studied for an MPH, this is a lot of big data, and so this makes a lot of sense to me. But can we break down this what you call hazard ratio, 0.71 to 1.08? Can just in a nutshell, are you able to explain? I mean, it doesn't seem, I'm not, and I don't see necessarily error bars there in that process, statistical significance. Can you, how does it that being less than one on that primary model is different than, say, the glaucoma surgery, which is greater than one? Can you point that out a
Yes,
little bit quickly?
yes. It's kind of like, so we had talked about that forest plot that if the hazard rate is greater than one, that means that there is a risk associated. And if hazard rate is less than one, then there's a protective effect. But if you have a 95 confidence interval, like here, that is, reaching, that is crossing the one, that means that this is not significant. As opposed to here means that, if this is a true effect, that all the 95 confidence interval goes below one and it's not really touching the one. So that means that it's significant. So let me kind of go back to the table. So when I say that it's 0.71 hazard rate, so roughly that means that it's a 30% reduction. But the key is the 95 confidence interval here, that it is from 0.62 to 0.83. So that is way below one, and then it's not near one. So that means that this is a very statistically and a very significant association, and the p-value was, 0.001, I believe.
So to summarize that further, the glaucoma surgery model, as you're saying, it straddles one, so therefore it's not significant. Whereas
Exactly.
to put this in the simplest of terms, your primary model of cataract surgery, okay,
Yes.
if you means that at the minimum you're going to get almost a 20% reduction
Yes.
dementia progression, uh,
Right.
just simply by taking out the cataract.
Yes.
Okay, I mean I can't. That to me is just mind blowing. I don't even. So you're going to reduce the potential for dementia, either
Yes.
acquiring it or progressing,
Mm-hmm.
nearly 20% by taking out a cataract.
Yes.
Okay, I will let you continue. That just is a powerful point that I think we need to kind of really hammer home. That's
Yeah.
impressive.
And then that's why we kind of really did so many analysis to make sure that it's not a confounder, meaning that there is, because like if you are signing up for cataract surgery, maybe your socioeconomic status is higher, or maybe your health, you exercise more, you are not less depressed. All those factors we were able to control in secondary analysis, and we still found those results. As opposed to glaucoma, even though it says 1.08, it doesn't mean that there's an 8% risk. We want to know what is the 95 confidence interval, and then, is that significant or not?
Yeah.
So you might wonder, well, what are the potential mechanisms? Well, I think it's, obvious that if you really had a bad vision and then all of a sudden your world is clearer, then you probably want to go out more, you're happier, you exercise more, you become more social, maybe you'll pick on a hobby. These are all secondary factors that are known to be protective against Alzheimer's disease and dementia. But there is, more of a primary effect that could be possible. I'm not saying this is what's happening, that you're getting more healthier and stronger neuronal connection in the brain. And then that is probably protective because it is, keeping up with the demand of the brain metabolism. One concept that we usually talk about is cognitive overload. So let's say that our brain has like 100% capacity of X. And but my vision got really bad because cataracts. And then 50% of my time, always thinking about, well, what am I looking at? Is that red or is that orange? My brain is too busy trying to just figure out what it is that I'm looking at. Then I only have 50% of reserve of my brain to figure out everything else. So I'm not going to have the power to say, oh, where did I put my key? Or, is it Monday or is it Tuesday? So that is the cognitive overload. And then that alone could be helpful because that frees up your reserve on your brain. And then that could have an impact on your, rate or progression or diagnosis of dementia. Another possibility is that there is a small population of retinal ganglion cell called intrinsically photosensitive RGCs. Now, they are about 2 to 3% of the total retinal ganglion cells, and they have nothing to do with vision, but they are actually involved in circadian rhythm. And what is really remarkable of these cells is that they are exquisitely sensitive, and their light that stimulates them is blue light. Now, knowing blue and yellow, yellow is the biggest enemy of blue. So we were thinking, well, maybe they are selectively being understimulated, and maybe that's why you're not likely to sleep. And then also there's an animal model that have knockout iPRGCs that that they have shown that they are more depressed, and then they are not as cognitively intact. So it is possible that it could, that could be one of the mechanisms. I do cataract surgery on my patients, and it's kind of funny because when I train, patients had much, much worse vision, and then the vision outcome was really remarkable for them. But I think nowadays we are more aggressive. So, people who are saying, "Oh, I have some glare," then I still do the surgery. So they don't come back and say, "Oh my gosh, my vision is so much better." But I have a lot of people coming and saying my world is so blue. I have photographer patient who said that they had to recalibrate their camera. I'm sorry. Um, because they realized that all the color vision was not normal. So I think that is an interesting observation. And then that makes you think about are those blue blocking lights really good, or and then I'm happy to talk to you more about that. So we are able to publish this
Dr.
paper.
Lee,
Yeah,
I'm gonna stop you there for a second
yeah,
as well. This goes back to 25 years ago when Alcon arbitrarily chose to put a yellow filter in their lenses.
yes.
Um, and those intrinsic cells of which you were speaking about a moment ago,
Hmm.
at that time, there was a big discussion about how it could impact individuals and their circadian rhythm.
Yes.
And I was doing some glaucoma research at the time, and they were talking about how individuals who are at risk because of
Yes.
nerve damage could actually progress or certainly have problems with sleep. And I know that sleep or sleep depression or sleep cycle
Yes.
disruption is associated also with neurofibrillar tangles and dementia.
Yes.
So
Absolutely.
you're looking for comorbidities or cognitive co-founding factors here. Did that
Yes.
come out in any of your research that maybe we shouldn't be using yellow filters? Because I've never used it in my
Uh-huh.
25-year career.
Yes.
Whenever possible, I
Yes.
stay away from those natural
Uh-huh.
filters and
Yes.
lenses. So
So,
are you
uh-huh.
telling me that for the past 25 years I've been doing something right?
Yes. Well, that's my humble opinion. But I don't do yellow lenses at all either. But I mean, like I used to do that when I was a, resident because that's where we train. I mean, that's how I train. And then we were told that, one of the reasons why we started using yellow lenses were because we thought that that would be protective, that, light in the UV light was bad. I mean, we thought that, I mean, we weren't even doing cataract surgery on AMD patients. But then now the ARIDS, analysis have shown that no, AMD progression does not happen because of the cataract surgery exposure. So I think we're learning a lot more. And I actually did talk to Alcon because I was surprised that still 50% of the US still do yellow lenses.
Yeah, high five, Dr. Lee. I'm high fiving the television right now. I still say I've never used, whenever possible, a yellow light filter in my patients. They're champagne color with one company.
Yeah.
There was a purple filter in another.
Mm.
But the idea was I never made sense if you were going to cut out any of the visual spectrum
Yes.
based on data that was intended to protect patients with AMD that never
Mhm.
proved to be at all
Exactly. Yeah.
beneficial. So why take it out of the system? And we did a study here about 18 years ago comparing image quality and contrast sensitivity,
hmm
looking at them. And we just took 20 patients with a yellow filter and compared it to a different brand, different lens. Now, again, you could argue the brand, but it was still spherical aberration neutral, and it was just different. And I think it's
Yes.
important to keep this in mind as we kind of explore these subtleties with our
Yes.
patients, particularly if we're suggesting that cataract surgery should be done earlier in the process.
hmm I would love to collaborate. I mean, like if you have data that we could look into, I would love to collaborate with you because I've been looking for data that have good dementia and then yellow versus non-yellow. We did do a study in collaboration with Taiwanese group, but they get cataract surgery so early that it really didn't matter. So I wonder it also has to do with the timing of cataract surgery, whether you had some vision loss and then you are getting rid of it versus, you are doing that before the vision loss happens. So many studies that could, help
We
us.
can certainly discuss that offline. I'm going to let you continue, but it certainly raises a lot of other questions for sure.
Okay, so then now I'm going to talk about visual function and Alzheimer's disease. And just kind of briefly reviewing it. So regarding ACT study, they come in, they are part of the HMO. They are, getting all equal care, and then they get enrolled. Every 2 years, they get cognitive testing, and then they get Alzheimer's disease or autopsy, and then they get eye exam throughout their history, right? So what is really fun and kind of painful was our chart abstraction. So Kaiser went through epic transition. I don't know what type of EMR you use, but they use epic since like 2003 to 2004. So that's easy. When you have all the data in EMR, we do, natural language processing. It's not as simple, but then, we are able to get data from everyone. But we did not want to, throw out all the decades and like lifetime history of their visual function. So we went all the way back to 1940. And for a subset of people that we could do, you can see how this person was 29. The patient did not get enrolled into our study until, after 65, but they had glass prescription that was done in 1965. So you can imagine how, extensive their visual history that we could get out of this extraction. And this is an example of a paper chart that we get from the archives. And then we actually measured the inches of the whole, we don't, that is our definition of how hard the chart was. Um, and then so this is our analysis. So we had about 9,000 eyes, about 4,500 people. And then we divided into the eyes that never developed dementia, eyes that develop Alzheimer's disease, and eyes that develop non-AD dementia. And by non-AD dementia, I mainly mean vascular dementia because of the cohort. And vascular dementia is the second most common type of dementia following Alzheimer's disease. And then if you look at it, we had about 250,000 encounter data. And then so we had about 250,000 visual acuity data to go into this analysis. This is the work of Aaron Lee, and so this is me looking at better seeing eye and worse seeing eye. And then this is just kind of reminder that this is the trajectory of the eyes that never develop dementia versus Alzheimer's versus vascular dementia, okay? And then the x-axis is the age. Look how it starts from like the age of 25. And here we go. So each line that you're seeing is an individual person. That's a lifetime trajectory of each individual person. And then it, fluctuates like crazy. And then you might say, oh, that's Mr. Smith that, forgot to bring their glasses, or, this is Mr. John who just got cataract surgery, got better. But you can kind of see that, well, as we get older, our visual acuity does get worse. But there are some changes or some differences among those three lines. So we had about 155,000 years of follow-up, and what do we see? I'm going to try to summarize it here. So this is the summary of those lines. So again, those are the eyes that never developed dementia, and then this is the age. These are the eyes that develop Alzheimer's disease, and then these are the eyes that develop vascular dementia or other dementia. And it's really interesting that, early on, there's really no change. So, so these are the kind of the 95 confidence intervals. So they are all overlapping. That means that there's no statistically significant differences among three groups. But what we are seeing is that along like the age of like 67-ish, there is a clear inflection point that the eyes that will end up developing Alzheimer's disease will bump down, that they're going to be seeing less. And this is not the impact of their Alzheimer's disease because, the minute they get diagnosed with Alzheimer's disease or dementia, they're out of this, on this curve. So these are, right up until they get diagnosed with Alzheimer's disease or other dementia. And if you look through the non-AD dementia and no dementia eye, the inflection point actually start a little bit sooner, a little bit younger age. So that's kind of like maybe at the age of 60, where, there was an overlap here, but then here there's no longer overlap, that they start losing vision faster than the eyes that never develop dementia. This
So
was really,
Dr. Lee, again,
yes.
just to dial into that, if you look at the dementias um, on your graph, the
Mhm.
slope on both of them, the
Yes.
Alzheimer's dementia and vascular dementia,
Yes.
it's relatively steep and early.
Yes.
So can we say if somebody starts to show, and it's not a substantive drop, we're going from point, it looks like 0.05, not even quite to 0.1, but if it's a
Mhm.
pretty precipitous drop,
Yes.
then you have to start thinking of the potential impact that it very well may be having
Yes.
on their longevity, their vision long term. Now,
Yes.
are you going to show a slide here in a second where it shows kind of the deviation if there's a cataract extraction? Do you have that data too, where you can
No.
take
So
their natural course?
yeah, no, I wish I did. No, I don't. And then,
Okay.
but this would be kind of part of if you had a cataract surgery, we're assuming that your vision would have improved. And then so you would be contributing towards whatever your group is. But this does not, stratify. I have another analysis where we've excluded the time in which they were diagnosed with cataract, I suppose, and then until they got cataract surgery done. So we are excluding the time in which they were impacted by cataracts themselves. That's an interesting analysis. I don't think I have that slide though. But kind of like to summarize what you just said was that yes, the steep differences that happen, it happens relatively early. So that means that there is an intervention window that we could do by, improving our visual health. And then also, I thought this was really interesting, and it made sense that the differentiation between no dementia versus vascular dementia happened earlier, because in my mind, people who end up having vascular dementia, probably they have diabetes, probably they have retinal vascular occlusion. So then those are going to impact their vision. Like they're going to have DME, they're going to have, macular edema. As opposed to, people who just develop AD dementia, they might have, they don't have those eye diseases that are from systemic, complications. So I thought that made a lot of sense. But it's really interesting that you can kind of show that just by visual acuity alone, and we all know that visual acuity is a horrible indicator of visual function, right? But even just the visual acuity trajectory alone can predict, AD dementia development. So the way we think is that we think that it's bidirectional. So it's not that I'm sure that, there are processes in the brain that are happening, that are reflected or that are also happening in the retina. And then that might be why people start, losing vision. Maybe because, I mean, you have like amyloid, maybe you have plaques and tangles because you have a poor vascular, circulation, and that's also happening in the retina. And then that's why you start not seeing as well. But at the same time, because we are seeing this vision differences even before they actually are diagnosed with dementia, I think that also means that improved vision or eye health also will impact their rate of progression or their rate of, development towards dementia. So I think as an eye care provider, it will be really important to see how we could really make an impact on, people's overall health. And a lot of studies that I've shared with you was really the reason why this was part of in 2024 report of Lancet Commission. So Lancet Commission report comes out every 4 years. They go through all the, research evidence that have happened in the world, and then they summarize and then they say, well, what are the known modifiable risk factors of dementia? And in 2024, they released two new modifiable risk factors. One was high cholesterol and one was vision loss. And so I think we should all be really excited that we can be part of taking care of this vision loss and then really making a difference in dementia prevention. And I can assure you that the studies that I have shared with you was really part of evidence towards 2024 report is because I did write that section. Okay. So then you might say, well, is it all about sensory impairment? Because, I'm like really emphasizing the vision itself, right? And I actually don't think so. So the preliminary data that, I don't have the time to go over in too many details is that when I look at the brain autopsy data, I told you that I have about 1,000 brains. And I, was trying to see whether there's an association with visual acuity or eye diseases with the brain pathology, like how much plaques and tangles do you have and how much microinfarcts and whatnot. And it is really interesting that eye diseases such as diabetic retinopathy and AMD were strong indicators of them having brain pathology burden, but visual acuity was not. So I think it makes sense. I think, when somebody has, severe disease burden in the brain, but you're still seeing well, I think that probably means that there's something about their brain that there's either more reserve or their brain is more resilient. So I think, kind of understanding this complexity between visual function, disease severity of the eye, and then also Alzheimer's disease development during their life, and then the, actual pathology burden in the brain will be all really important in us better understanding the overall connection between the eye and brain. Okay, so I'm going to move on and then I'm going to kind of go quickly. I'm sorry, we're kind of running out of time, but just kind of do an overview. So, I mentioned AI and machine learning. I'm sure you've heard of Biobank, UK Biobank. So, UK Biobank is, I think it started in 2004, I think. And then, UK government wanted to recruit 500,000 people, 500,000 people and then they kind of went through everything, right? And then they kept bringing people back, and then they're all really healthy people. But this is the, really the prime example of big data and letting AI models or doing discoveries. And in 2019, Google's group really kind of shocked us all. Using UK Biobank retinal fundus imaging alone, they show that AI model can, accurately predict the age, sex, whether they are smoking, their hemoglobin A1C, their BMI, even their systolic and diastolic blood pressure. Now, I'm a retina specialist. I can guarantee you that I cannot even get close. Like I have no idea how I would be able to see a fundus photo and say, oh, that's woman or that's men. I mean, to me, that like really boggles my mind. But clearly there are latent information that is hidden. And then clearly we are looking at those images or like at your patients like every day and then we're missing it. And then that really makes us excited. But then also kind of really highlights the power of, AI and big data. But the trouble is that, there's huge bias in UK Biobank. I mentioned 500,000 people who were okay with getting, poked, getting imaged. I mean, like really being tortured by all the examiners, right? They have to be healthy. You're not going to be a sick person who's, showing your hand and, so even common diseases are really uncommon in UK Biobank. And then they're all, British white. And then I found a paper said that if you are like in the 70 and 80 years old group, but you have participated in UK Biobank, you're about 20 years more likely to live longer than anybody else. And it's not because you participate in UK Biobank, it just means that you're that healthy. So obviously the AI models that are only being trained with those type of participant data, it's going to be very skewed and biased. And that might not be generalizable to your patients who might be, more Hispanic, more Black, or, maybe sicker, right? So we are part of this Bridge to AI program that where we are concentrating on developing multimodal AI-ready data to really generate large multimodal data set to enable AI model development in a less biased way. So our study is really understanding salutogenesis and pathogenesis of type 2 diabetes. Just going really quickly, we are recruiting 4,000 participants, but then it's really important to really balance the data. So I had mentioned healthy patient data, right? So to understand type 2 diabetes, out of 4,000 participants, we are equally balancing to 1,000 normal, 1,000 diet controlled or pre-diabetic, 1,000 medication controlled, and 1,000 insulin. So that even though 4,000 really by AI, standard, it's not huge. It really provides us a lot of power because we have a balanced data. And we go from head to toe. Really, they spend about an hour doing all these surveys, but then they spend about 3 to 4 hours. They go through 41 different retinal scans in our hall. And then they go home with continued glucose monitoring, physical activity monitoring, and then an environmental sensor that they plug at their household. And we take 22 different environmental sensors, such as pollution, temperature, and light spectrometers measurements every 5 seconds for the next 10 days. So, it's a really unique multimodal data set. And this is just year three data. We have released data on 2,200 people. It's only 4 terabytes of data, but you can actually request it today if you want to take a look at it. We made it sure that it's accessible to any researcher. And so that's the type of the data that we have released. In less than a year, by November, we are going to be releasing the entire 4,000 people's data. But we are going to also include whole genome sequencing, all this omics data, along with the EHR. And then I'm just going to go really quickly that, please, if you're interested, please do go and please share with all your data scientists, people who know how to do AI, because our goal was really to share the data set so that people can do research on it and publish and do more science. So hopefully, this kind of gave you a little bit of, glimpse of the ophthalmic big data and AI revolution. And we are all, at the very center of it, but also kind of reminded you that to make sure that we can leverage all the power of this, we need comprehensive data sets and we need longitudinal data sets. And also we need to validate. So it's not going to be just like one model that says, oh, I can do this in this population, but we're going to be able to validate. And for that, we really need to collaborate with clinicians, healthcare workers, and really the not just the ophthalmologists, but multidisciplinary investigators as well. I want to thank my collaborators. It's a huge team, and then also our team at University of Washington and WashU. And this is where you can, use the barcode to get the data. And that's what I have. Thank you. Sorry, I thought I would have more time left, but
Thank you, Doctor. I'm just gonna, please don't go anywhere. I just want to, first of all, congratulate you on just a remarkable amount. And I mean, it is Herculean as far as what you've been able to accomplish. It really is impressive. And if this isn't a plug for collaborative care, and multidisciplinary care. I don't really know what is. And, there's a lot said, at least in this part of the country, about what managed care, or even the equivalent of, say, like a Kaiser would look like. I think potentially even, I don't know if I'm going too far as to say kind of looked down upon. But in this regard, it is remarkable. Across subspecialties, working together, getting data that goes back. I think you said, pre 1950. It's just shocking to me that you can get that kind of information. And as somebody who has his NPH, did bench research prior to this, this is what this is all about. Now, I'll go so far as to say you cannot take this information and without some judgment, that is, AI is amazing, but everyone in this room is able to apply all that big data very quickly to somebody sitting across them and read their emotions on their face and try to understand what they're hoping to accomplish. So you then have to distill all this information down to the individual that's in front of you. And that's, I think, the human element that will be very difficult for AI to replace, no matter how good it is at reading a fundus photograph or an FA, or in case of cataract surgery, I know there's two companies, Foresight and Horizon Surgical, who are doing fully robotic cataract surgery now, non-human assisted. And so, yes, AI is here to stay. With a show of hands, we're going to do this in reverse. How many in the audience do not use AI at some point in the day that they know of? Make no effort to use AI. None? Okay. You know?
Not that young. That sounds cool.
I mean, I guess I could challenge that and be like, if you turn on Google,
I guess, yeah.
Gemini is going to do some
I
work.
normally skip it.
If you use an OCT, it's already plugged into it because it's taking the big data and it's putting it across populations and it's giving you stratified information for age and gender. Because I noticed in your set, I don't know if anybody else caught this, but I assume you had female on there, which you easily could have just put male, and it's binary,
Yes.
and it didn't show you anything. It was a risk ratio of 1.
Right.
So the dementia, which to me it seems a little backwards, depending on age, because of cardiovascular risk factors, women tend to do better than men, particularly at a certain age group, until certain hormones kind of fall out of the mix. I would think at an earlier age, female would be somewhat protected, but it's not.
So then, we would have to look at, maybe like doing like a spline model in terms of like if our hypothesis is that they might do better until they are 50 years old or until 60 years old, because we are just looking at the continuous variable. Yeah, I mean that we would have to be more specific about that.
So again, I'm going to hold you for a little bit longer. Does anybody have any questions? I love it. Yeah.
Research done, or maybe I missed this in what you spoke about earlier. The person that's already been diagnosed with dementia, then they have the cataract surgery. Does that slow the progression, stabilize the?
So that was outside the scope of the study, but so my understanding is that what happens if you already have diagnosis of dementia, would the cataract surgery be helpful? So then I think that is a careful discussion with the neurologist and whatnot, because there is a concern of, general anesthesia, whether that would have a negative impact on, their cognition and whatnot. But if, but the majority is that they actually do really well after cataract surgery. So, like I had a patient who um, who was not, who had like a mental issue, and then, so since like really like she wasn't really communicative, and then she had a retinal detachment, from myopia, and then we had a cataract surgery, and then, all of a sudden she was like smiling for the first time in like 20 years. So, I mean, and then you probably heard of those cases where, I think vision is very important and then really helps in terms of your health, and then being able to, go around and, be interactive. So in my mind, I do think that cataract surgery would be helpful. But, in terms of, if you have such a severe dementia, whether, that would be really active because you have to go through, general anesthesia, and then you have other comorbidities, then, I mean, I think that's really case by case. But if you have like a mild cognitive impairment or like very early onset or early diagnosis, then I would absolutely recommend it. I mean, if I were like my family or somebody, yeah.
It can, because that's I think an interesting thought. So as I heard what you said was it's certainly not going to reverse dementia, but
Mhm.
would it take you off the natural course of this decline? And so I think, because I'm going to take, I have two thoughts that come to my mind based on what you said. I'm
Mhm.
going to take it ad absurdum. I had a patient that was a minus 20, no cognitive deficit.
Mhm.
We put in an ICL, and they are now planar for the first time in their life with not wearing distorted glasses or contact.
Yeah.
And this was back in the day when there weren't a lot of people doing it. They'd already been told no by other refractive procedures. But here's what I saw. Their face lit up.
Yeah.
The idea that they can move around now without this baseline level of anxiety. Hey, I'm not in glasses, or where are my contacts, what's going on? Because
Mhm.
it's been changed.
Yeah.
And so in an instant, and so their world, their apprehension, they become more outgoing. And that was always for me. It was like,
Yeah.
am I just interpreting this a little bit differently? Am I being overly optimistic? But I would have to assume, because I'm going to bring up another patient that I saw today, similarly, had a stroke, is using a walker. And my common comment with somebody who comes in with a cane or a walker is that our goal is to try to reduce your relative risk, given that you already have one assistant. Why make your glasses a second one if I can make it so that your vision for distance, activities of movement is what I frequently say in the room. Now you don't have a second assistant as part of your day to day. You're going to grab your cane and your glasses and whatever else you got to put in your pocket to get around. And I said this actually, I feel a little badly about it because I was speaking to the daughter and the patient was here on my left. And she wasn't particularly verbal, but when I said, we're going to take out the cataract, try and improve your vision, and it'll open up your
Mhm.
your basic engagement. She smiled. She wasn't a particularly verbal person, but she caught on to that and
Mhm.
was very excited. It was the first time she actually spoke in the room to say, look, this is something I want to do. So as you decline visually, your engagement in the world changes.
Yeah.
And I think, as you point out, it's not just a comorbidity. I think the vision feeds into the the neural activity, and the neural
Yes.
activity feeds into the vision. And it's this vicious cycle that if we can
Yeah.
take them off the course, I
Yeah.
think we should do
Yeah.
that. You used the word, you said we weren't as aggressive when I
Uh-huh.
was doing cataracts as a retina doctor. I just would like to alter that a little bit and say maybe we weren't as assertive as we
Yeah.
are now. Is that a better way to
Yes,
put it?
yes, that's a good way to put it.
There you
I
go.
really do think that it's bi-directional. And then, there was a paper that came out a couple of years ago, and then just by looking at the number, like doctors are way less assertive in offering cataract surgery if somebody has already a diagnosis of dementia. But like, profoundly, I think also, I think, we try to be more conservative because we're like, oh, they already have Alzheimer's, dementia. They might not notice it. I mean, we don't know that. It actually might be really helpful and impactful in their life. So I think we should be a little bit more careful, and then also like talk to the family, caregivers and whatnot, because I think it's worth a try, instead of just saying that dementia, that means no surgery. Yeah.
Any other questions? I have actually I have two here. One's going to be ridiculous. So, Brian, I do. This has brought up so many different thoughts here, but we talked about, or you spoke about comorbidity of glaucoma, diabetes, macular degeneration. Again, what very well may be or maybe not, or at least loosely associated with potential vascular diseases. So therefore, we've always said I can actually, no other way can you in vivo put your eyes on a vessel other than the microvasculature. There's no other way a clinician is able to do that other than those of us in the room that is using a slit lamp or indirect ophthalmoscopy to visualize a vessel. And this is before OCT showed up to be able to show vascular flow. So that is an interesting concept that you can look at it. Now, is there anything else on an exam that you could look at and say that's a biomarker for future disease, like a true biomarker, like no differently than saying you're able to see a Hudson-Stolly line or a Wilson ring, be like, hey, this is a direct indication that something's going wrong. Can you do that, or do you for a
So
future prediction?
not yet, but I think that's where, our goal is, right? And then that's why I keep saying that longitudinal data set is critical because right now, we are kind of dependent on all the data. And then we are trying to see, what are the signals that we can ascertain between cases and controls, like, simplistic way. But how do we actually validate that we can actually identify those biomarkers at the early stage and not the later stage when they are already diagnosed, right? Because in terms of the prediction, you need the timeline. So I think, ultimately we're going to need some type of longitudinal, follow up and, data set that we can actually validate those findings.
Okay. So can I say that potentially presbyopia could be a predictor of mental decline? For me, as I know that my mental health has gotten a
Uh-huh,
lot worse since having to
uh-huh,
put on reading glasses.
uh-huh.
And so therefore, would treatment of presbyopia be indicated to reduce the trajectory of mental depth deficiency? Could you make that comment?
I'm not sure, but I think, you know,
I know it was a push. I was just
yeah,
wondering.
yeah, yeah. It's more like the inability to keep up with the glasses to help the presbyopia might be, a risk factor. So yeah, I don't know. I mean,
That's
that's kind
pretty
of
good. You
pushing it.
that's
Yeah.
very political of you. I gotta hand
Yes.
it to you. Because Drew, we've tried the drops. I don't think I'm any better with my presbyopia drop right now. I'm equally as frustrated. Well, again, thank you very much. I'm going to just open it up to the room. If there are any last questions, because I got another one. That was the second one. That was real. That was it. Really was. I'm sorry.
Yeah. Um,
So, is there
I
genetic
couldn't hear
testing that
anything.
is
I'm sorry.
readily available for APOE for the dementia alleles?
No, it's usually sent out testing. I mean, like if you go to see a neurologist, then yes, they will test and then also like the amyloid therapy like lecanemab those like there have been three FDA approved infusions that have come out in last 2 years, so they'll routinely test for ApoE4 because that is a risk factor for you having potential complications of with amyloid therapy, but we usually don't routinely check that.
It's, one, I guess I gave myself two more questions. Coffee, there was one study that showed that um, there was a linear relationship between the cups of coffee one drinks and their cognitive capacity. And I do not believe that reached an asymptote. So if I drank 45 cups of coffee, I was 40 times more likely to maintain my cognitive function. Are you familiar with that study?
No,
Okay.
I'm not.
All right.
But I would
Probably
be
should have
very
asked that
worried
one.
about confounding effect. Yeah.
That's right. That's right. Cardiovascular disease would be one. Okay. And then the second one, which we didn't touch on, but I think you alluded to it. I know, again, that was a real study, the coffee one. Second one is, I know it a little bit probably better, made it out into the community a little bit better. Hours of sleep and dementia on incidence of dementia,
Hmm.
prevalence of dementia rather.
Yes.
And they made it a very hard cutoff of 8 hours, which shocked me because I know in our generation and what we do, you're like, I got to study more. I'll just get it over the weekend and I'll do 2 hours tonight and I'll just sleep all weekend later. But the study said that it's not, you can't reserve it for later in the week. It's got to be 8 hours of sleep every night. Is there any comment on that?
Well, I think it's, well, kind of like what you said. It's really hard to characterize the sleep in general because, like even people who, like, I think there were another study that have said that it's not really how much you study, but it's like whether you have like uninterrupted sleep.
Yeah,
Meaning like, like if you're awake every 2, 3 hours, it doesn't matter whether you sleep 8 hours or 10 hours. Or, if so, I think those are really hard, and I'm sure they are very important indicators as well. And then also another question is kind of like how do you actually measure whether you actually slept for 8 hours? Is it by Fitbit? Because like a lot of older adults like will forget to put it, and then so they'll say that, oh, you slept for like 24 hours or, and then so there are all this like variability. So then you have to worry about like measurement error,
yeah,
whether it is actually, what you think you measured is correctly measured.
okay. That, everybody comfortable with that answer?
But I do think
Well,
that better sleep is definitely associated with, protective effect. So I do think that we should all get better sleep, but I
yeah.
don't know how much. Yeah, and yeah.
No, that's, again, this has been an absolutely wonderful presentation. Can we just give her a round of applause again for Dr. Lewis? We really, yeah, appreciate you joining. Anything we can do to help promote your study in any way, please let us know. But we are so grateful for you giving us the time this evening. I know I learned a lot. I'm sure everybody else has as well. And so we wish you all the best and thank you again for what you've been able to accomplish here. It's
Thank you
amazing.
so much. This has been a real pleasure. Thank you.
Thank
Thanks.
you again. Thank you.
Bye.
All right.
Bye.
Bye. Well, that was impressive. I don't know if I can follow this up with any feedback here. Yeah.